Hello everyone, in this video we're going to walk through the wonder and awe of data science and see if we can assess this data set for quality and profile it and come up with a plan of action to improve it before we analyze the data. Now it is the Austin Animal Center intake and outtake data set. Before we begin, I want to make clear that this data set originally was two CSV files, comma separated values. I put both files into this Excel, so .xlsx, and I have in and out. Okay? And I wanted to do that for simplicity before we start our journey here today. So the first thing I like to do is profile the data, get an understanding of how much data actually exists. So the simplest way to do this, and I'm going to try to do this as low tech as possible, because not everybody has PyCharm and Anaconda, R squared, just kidding, R Studio, and other tools. And you got some data and you're working for a company and you're trying to figure out what to make of it. Okay, so we've got approximately 125,000 rows of data, 124,120. And again, if you're new to Excel, it says 21 there, but we take one off of that because we're talking about data and not variable names there or headers. Okay. So that's a lot of data. Now, if we go from A all the way over to L, now we've got all that data as well. Okay. So a lot of data we're looking at here. Okay, 12 columns of data. So we have over 1 million cells. So nothing to sneeze at. Okay. Now that we understand that, we start looking to see what kind of formats is in our data. Well, we've got numbers here, but there is a character at the beginning. So that's a code. In other words, an ID, a special ID that's been generated by the Animal Center. We have a name. We have date and time merged together. We have month and year merged together. We have a found location. Intake type looks like text. Intake condition looks like text. Seems some similar values there. And we have dog, cat, other, and similar values there, but we'll double check that. And we have the sex upon intake, and they refer to as intact, unknown, spayed, neutered, etc. And then age upon intake. They have different information there because there's numeric data and also text data. So in this format, we're going to want to talk through that in a little bit. In breed, we have a lot of different values there. And over here, we have a lot of different values too, because sometimes they call them tricolored, and other times we got white and liver, but then we got brown tabby white, and then we have brown tabby without the white. So a lot of different possibilities here. So the very first thing I like to do, keeping it low tech, is I like to go up to sort and filter in Excel and add a filter. You could also go to data up here and hit the filter button as well. Now, I like to just open this up, and this one we already know it's going to have a lot of values. In fact, I can't show them all. But over here for name, look at this. This is beautiful, folks. Beautiful. What I mean by that is we all saw this as text, right? Okay, yeah, we got some asterisks in there, but look at this. There's some funky numeric stuff going on in here. Scroll down, I got all these different names, all kinds of stuff going on here. So we're going to want to be careful with that because we've got asterisks and we also have some numeric stuff happening there. Over here, we have time and date, or date and time put together, and it looks like military time because it goes beyond, at 12:59. Sure, we've got that, but then we've got 1700 hours, 1752. We've got lots of different times in here. So it's military time, 22:39 military time. So we're going to want to think of a way to break that data apart, because I believe that it'll be important to study the date by itself, because then we can look at day of the week from date, and time, then we can start looking at seasonality of dropping off times. What's the most common time that people are dropping off their pets or a pet? Because remember, this is the intake side of the organization. Same thing with month and year. We've got some interesting things going on here in the data set too. It looks like the timestamp is the same across everything, but we will want to make sure that's true. Never, ever assume too much when you're dealing with a dirty data set, a data set that you know that you're going to have to transform. It's just not the safe thing to do. Found location, okay, we've got the state, which makes sense. Austin, Texas is what our animal center is named. So we've got Austin, Texas, a lot of Texas, but we also have outside jurisdiction. We have just Austin, Texas. Sometimes we have a street address. I presume that's because either it was reported that way or somebody from the agency collected the animal and they went out on a call versus a surrender. But we don't know that for sure, so we want to be mindful and accept the fact that we might not know that for sure. So in project management, they call them known unknowns or unknown knowns or unknown unknowns or known knowns. So you want to kind of look that up if you're unfamiliar with those terms. But we want to be careful here. And there we go, Travis, Texas. So it's not all Austin, Texas. Okay. So that's what a really good data scientist and data analyst will do. They won't take anything for granted. Intake type. So there we got owner surrendered, public assistance, stray. But look, if you go to the filter, you see all kinds of different types. So not only do we have owner surrender or stray, or we have wildlife, but we have euthanasia request and abandoned. So stray versus abandoned, is that a surrender? We don't know for sure. So we want to be careful when we do, if we were to present this data, even after it's all cleaned up, even after we clean up all this stuff over here, we want to be very mindful whenever we present our findings that we know that we could cause some confusion, not because of ourselves, but the data itself might be confusing. You know, I'd be like, okay, what abandon versus, owner surrender, or abandon versus stray. Okay, did somebody just abandon an animal on the street? Well, how's that different than a stray? Is it because they have a collar on them, tags, they look well manicured, there's signs of good dentistry? What is the rationale behind that judgment that we're making? Intake condition, look at this. This is where a data analyst really, really needs to be on top of her game, because you could, injured versus medical. Well, what does that mean? Nursing, pregnant, okay. We've got sick, is it truly sick or is it aged? Feral versus behavior, has the test been done on that? Injured, that word medical there, and normal, what does normal mean? So what does other mean, of course? So that's where the data analyst, once they get started on this project, might start finding, you know what? I don't think we should be talking about other, pregnant, and normal. So now we've got 108,000 records that are of those conditions that we can delete from our data set, leaving us about 20,000 records. So never assume just because you have all this data that you have to use all of it. It really depends on the study you're trying to work on. So maybe your project is about studying only pregnant animals. So now we have 77 of them. Okay, great. Sounds interesting. But now, let's say you want to focus on cats. Well, now we only have 22. So you're probably not going to get a lot of predictive power out of that. You're probably not going to get a good representation of animals across Austin, Texas, based on 22 animals. So this might be where the data analyst says, hey, I don't have enough data here. I think I'm going to have to go and find some other agencies across the United States or Texas and see if I can bring in more data based on pregnant animals that are cats. So that's where you're pruning your bush a little too much, and you might not get anything useful out of it. Okay? But look at this here. We've got bird, cat, dog, livestock. There's many ways to do this, but sometimes you just want to do the low-tech way. Birds, 586 birds. Okay? And livestock, 22 livestock. Interestingly, they're all normal except for this last one here. It's very interesting to think about livestock in that regard. What's cool is over here you can see what type. So a lot of pigs, pig mixes, pot-bellied pigs, pygmy pigs, goats, things like that. So again, another low-tech way to just kind of start canvassing your data, profiling it a little bit, taking a look at what exists there. So look at this. We've got intact, neutered male. Okay. We've got null values. We've got spayed female. Okay. So we have the pairing intact, neutered, intact, spayed. We have unknown. Okay. We have null. How many nulls do we have? 1. Okay, awesome here. Awesome. What does that mean? Well, we have one row out of our 124,000 that has this condition of null. They're out of this part of Texas. What I would do here, this is not going to give you anything useful other than a descriptive statistic that says the animal center had X number of animals. I would just get rid of this one. I'd just get rid of it and move on with your life. Because you're not going to be able to predict anything based on the null sex. However, if you do have a study where you care about something in particular, and you're not going to use sex upon intake, let's say this variable, you're just not going to use it no matter what you do, then maybe you can keep this one in. But it still is only one record. So my point isn't specific to this one record, but if you have something interesting going on with one variable, but you're not planning to use it, just make sure the other variables aren't affected or they're not goofy either, and then you can go on and use it. Okay, but you have to use your best judgment there, and it really depends on your business purposes and what you're trying to solve. Okay, so this one here is the one that is really bothersome. Look at this. Look at how stratified this is. So many choices. -3 years. Look at that, -3 years. So what does that mean? It's one record. Okay. Now, what likely happened here, somebody hit a negative sign because the data entry system didn't have a validation rule to prevent negatives being the first one. So I'm thinking somebody typed that in there that usually puts like a bullet point or a dash or something like that whenever they record data, perhaps in certain situations. Or it was just a typo. They hit the wrong button by accident, their knuckle scraped that or whatever. So then that's the question, do you fix it? Do you just assume it meant to be a 3? And then you just go on with your life, knowing that there's a possibility that there's an error in the data set? Or do you quarantine it, move it out of the data set and see if you can find more information later? Or do you just delete it and move on? I would delete it and move on. It's one row of data, not going to be consequential. But what we need to talk about is the different ways you can report age, because this will not allow us to calculate anything. I mean, there's another -1 years there. We got 0 years versus 1 day, 1 month, 1 week, 1 weeks. So look at this one here. Great example. Look at it, happens a lot. 1 week versus 1 weeks. Is there a difference there? No. However, in somebody's lexicon, they've decided that that's how they want to report it, as in plural, weeks, an S at the end. Now we can try to look for a pattern here. This is Austin, Texas. There's Travis, but there's Austin, Texas. So we can't assume it's one agency or one location where it was found versus another. So we're going to have to clean this up, basically. And then we have breed and color. Now breed's just going to be real messy, real messy. because this is a human being that's, look, domestic long hair versus domestic long hair mix, domestic medium hair mix. Are we going to care about that? And then what's this bat mix, bat versus bat mix? Is it that important that we have mix separated? So pit bull versus pit bull mix. No, does that mean pure pit bull, or does that just mean that the reporter didn't do their due diligence and put in the word mix? We don't know. We may never know. Okay. So you're going to have to do a judgment call. Okay. Is the mix going to be important to your study? Yes or no? If it is, then keep it. If it's not, then you're going to have to merge these two responses into one response, because your data set is just going to keep ballooning every time you do an analysis or a prediction. Okay. Color will be the same thing, I guarantee it. Okay. How many colors do you mention? I've seen cats that have 4 different colors on them. Is that where we're going to go just because there's a tiny little speck of a different color? How far we can go between a dark yellow and an orange? So you're going to have to spend time on this too. You'll have to run a frequency distribution to see how often something happens, like blue merle happens 3 times. Blue merle white happens 4 times. Okay. Is it really going to break your study if you keep them separated as a 3 and a 4? Or could you merge them to give yourself a little bit more predictive power or a cleaner look to your analysis or data visualizations? So folks, that was just a low-tech walkthrough of a data set. And certainly I glossed over a few things, didn't show you how to actually break this apart. But the first step is understanding what you have. All too often we rush to use high-tech tools, fancy tools, without understanding the business objective, without understanding what the outcomes are, and plain and simply what we have and what we can do. So we might have to answer these questions before we start doing our analysis. So you might have to do some descriptive statistics, a frequency distribution of all of these. A pivot table in Excel is a wonderful way to do that, to play around really quickly, to move some data around to see if you can stratify it, cross-tab it, and redo it to give you some insight before you go into your big project. Because we don't even know. Austin, Texas seems pretty profound, but we saw Travis in there, but I don't know. I could do a keyword search here for the word Travis and hope I don't pick up a street name. Okay. So almost 11,000 records are from Travis, Texas. Okay. I could go a little bit better to ensure that, but give or take, maybe we say, what, all these records that suggest they're from Travis, Texas, let's get rid of them. Let's just get rid of them. Why? Because the more we fine tune our data set, the more consistent it is, the more reliable it can be. Again, thanks for watching. Have a great day, and I hope you learned something.